In this video, we're going to take a look at finding the domain of a combined function. That is a function which was obtained by adding or subtracting or multiplying or dividing two separate functions. In order for me to have something in the domain of this combined function, it first has to work in both of the original functions. That should seem pretty intuitive. There is one extra piece though. If we're talking about a division between two functions, we will further need to exclude any x that would make the denominator function equal to 0. Let's take a look at a couple examples. In this first one, I have a quadratic function f of x equals x squared minus 1, so a parabola. Any x will work in that, so the domain, you can see in interval notation here, is negative infinity to infinity. The other function, g of x, is a linear function. Again, on a line, any x will work, so my domain is also negative infinity to infinity. So therefore, when I want the domain of f plus g of x, or f minus g, or f times g, it's going to be negative infinity to infinity. There are not going to be any other restrictions. It's those last two, when I have f divided by g or g divided by f, that I'm going to have some problems. So let's take a look there. So the first one is f divided by g of x means I put f on top, g on the bottom. The denominator of a fraction cannot be 0 because we can't divide by 0. So I ask myself, what would make this equal to 0? Subtract 5, divide by 2, and I come up with negative 5 halves. So anything from negative infinity up to the negative 5 halves will work. I can't include that negative 5 halves, so remember we use a parenthesis there to show we get right to that endpoint, but don't include it. And then union, we're going to hop over that and go to the other side from negative 5 halves up to the positive infinity. So we have a hole there on our number line. It's anything except that one particular number. Now, if we flip it and we want to look at g divided by f instead, if I can get that off, there we go. That looks like 2x plus 5 over the x squared minus 1. The same rule applies. I cannot let x be anything that's going to make this denominator 0. So this time I have a quadratic equation to solve, and one of the ways I can solve it, if it's just an x squared term, no x's or anything, I can isolate the x squared and then take the square root of both sides, remembering that the square root of 1 could be both positive 1 or negative 1. So to help me with the intervals, I'm going to draw a number line here and say, okay, exclude the negative 1, exclude the positive 1, but anything else is okay. So then where does my number line start? Negative infinity up to that negative 1, parenthesis. We're going to exclude it. Hop over from negative 1 to 1, parentheses. Again, those are not included. Hop over, and then from 1 to positive infinity. So I have two holes giving me three intervals. Let's take a look at one with a square root in it. So the two big things we worry about are fractions with having a 0 denominator and square roots getting a negative underneath that square root, because those are imaginary numbers. So if these are my two original functions, my domain for f is again going to be negative infinity to infinity. It's just simply a line. But when I come over here to g, I say, okay, wait a minute, this stuff here has to stay not negative. In other words, it has to be greater than or equal to 0. Solving that inequality tells me that x has to be greater than or equal to 0. On a number line, that means I start at negative 4, and I go to the right to positive infinity. So my interval answer is going to be with a bracket, because this time it says or equal. I can include the endpoint up to infinity. Now, what about f minus g? Well, f minus g is going to be just the same as this one. It looks like I did not write that on there, but the domain of f minus g is going to be the most restricted between these two domains, and that is going to be from negative 4 to infinity. If I want to do f divided by g, I'll put the f on top and the g on the bottom. This cannot be equal to 0. Well, the only time this is equal to 0 is if I'm taking the square root of 0, and that would be when there's a negative 4 there. So the only thing I have to change on my domain is excluding the negative 4, so we change the bracket to a parenthesis. It gets a little more interesting if we reverse this. If I have g divided by f, then I have the square root on top and the x minus 3 on the bottom. Okay, so I know that I cannot let my x be 3 because that would make that denominator 0. But remember, I'm starting from the idea that it could be all the way from negative and 4 up to infinity, but I'm going to punch a hole there at 3. So if I have to now exclude 3, I'm going to start at negative 4 and go up to the 3, and I'm going to put a parenthesis on that. And let's see if I can get that up a little bit for you. So negative 4 up to the 3, parenthesis, we can't include it, union, and then we hop over on the other side from 3 to positive infinity. Let me know if you have any questions.